Okay, midterm review. As we've talked about, chapter 5 is going to be a big section. So there's some stuff on limits, a couple of things on derivatives, and a couple of the applications of those. I'll highlight a couple of these that you'll need to know how to do similar questions of. And then there's definitely going to be a related rates question. There's definitely a optimization problem. And then there's definitely some stuff about connecting the graph of a function to its derivative and second derivative. So max mins, inflection points, intervals of increasing, decreasing, or concavity, all of those sorts of things. So a good chunk of this test will be chapter 5. The other thing that I want to mention is that mean value theorem is not part of the normal calc curriculum. It's just AP, so that has been taken off of the midterm, so you don't need to worry about that. Okay, throwback all the way back to limits. So we looked at 3 cases of limits. So case 1 was if the function is continuous at the particular value of x. So it doesn't matter if it's discontinuous somewhere else, but if it's continuous at the particular value of x that we're looking at, remember that a limit is if I've got a graph like that, I want to know how that graph is behaving, what the value of that graph is as you can't see that, as I approach a certain value of x, okay? So the limit of this one would exist because as the graph approaches from the right and from the left, it is approaching the same value, okay? So if the function is continuous at the particular value of x, we've got basically the limit of the function is just going to equal the function at that point. So if it's continuous, in this example, f at 2 exists, therefore the limit as x approaches 2 of that function is just equal to the value of the function, okay? So in this case, if we've got the limit as x approaches 2 of x squared minus 7x plus 5, we're just plugging in, because this is a continuous function, it's a parabola, we know it's continuous, we're just plugging in a 2. So 2 squared minus 7 times 2 plus 5. So 4 minus 14 plus 5. So we get negative 5. Okay, so that's the first case, pretty easy. Probably a 1 marker. Case 2, if the function is not continuous at the particular value of x. So there's 2 cases of this. So if when you put the value in question, so a 3, a 0, whatever, in and you get 0 over 0, that means the limit's going to exist, but you need to factor or rationalize or manipulate it somehow, okay? So first example, if we plug a 3 in, we get 3 minus 3 is 0 on the top, 3 squared minus 9 is 0 on the bottom. So we know we need to manipulate this thing somehow. So we're going to do limit as x approaches 3. Now this one, we've got a difference of squares on the bottom, so that's a nice easy factor. This guy's going to cancel out. So now we're looking the limit as x approaches at 3 of 1 over x plus 3. If we plug that 3 in, we're just going to get 1 over 3 plus 3, so 1 over 6. Here, if we plug a 0 in, we've got root 2 minus root 2 over 0. So this is 0 over 0, right? So we need to rationalize. Remember that when we're dealing with square roots, our best bet is to multiply by the conjugate. So we're going to have the limit as x approaches 0 of, so we're going to do, I would write small here, that times the conjugate. So x plus, or root x plus 2 or plus root 2 instead of minus root 2. So then we're going to have if you think about the binomial times binomial on the top, the first 2 are going to turn into just an x plus 2. The outside terms and the inside terms are going to cancel each other out. We're going to have positive root 2 times root x plus 2 and negative. So those guys are going to cancel. And then we're going to have root 2 times root 2, and one of them's negative. So no, it's not a root anymore. It's root 4, which is just 2. Okay. And then I'm going to leave this whole thing on the bottom. Okay, because notice how on the top, my plus 2 minus 2, that's going to cancel. So then I've got x divided by x, that's also going to cancel. So then I just have the limit as x approaches 0 of 1 over root x plus 2 plus root 2. If I plug a 0 in here, then I just have 1 over 2 root 2. We never want to leave rationals on the bottom, so we're going to multiply top and bottom by the conjugate. So we're going to have root 2 over 2 times root 2 times root 2. So this is just a 2. That also becomes a 2. So we have 4. And then this last one, so if we plug a 0 in for h, we're going to have 1 over 16 minus 1 over 16 over 0. So this is, again, 0 over 0. This one's a little bit trickier. We want to try and simplify this top bit so we can get an h and cancel them out. Okay, so we're going to go the limit as h approaches 0. Again, you're going to have to write small on this one. So if I want to add these two fractions on the top, I need a common denominator. So I need a 16 on the bottom, so I have to multiply the top and bottom by a 16. And then this one, I need a 4 plus h squared, so I need to multiply top and bottom by that. And then that whole thing is over h. So now we've got 16 minus 4 plus h squared over 16 times plus 4 plus h squared all over h. So then I'm going to distribute this guy. So we've got 16 minus 4 squared is 16, and I'm going to put this all in brackets so I remember to distribute that negative. Then we've got a 4 times an h twice, so 8h, and then an h squared. And then that whole thing is over. I'm going to leave this other one not multiplied out, and you'll see why in a minute. And then instead of dividing by h, I'm going to multiply this whole thing by 1 over h. So 16 minus 16, these guys cancel. Remember that that negative still applies though. Okay, so you've got negative h, or negative 8h and h squared. And then you've got 16 times h times 4 plus h squared on the bottom. Okay, notice how I can factor an h out here. So it can be h, and then I'm left with negative 8 and then minus h. There go my h's. So now if I plug a 0 in, I get negative 8 plus 0, or sorry, I guess minus 0, but it doesn't really matter, over 16, 4 plus 0 squared. So you get negative 8 over 16 times 16 is, what even is that, 256. So we end up with negative 1 over 32. Pretty sure 256 divided by 8 is 32. It is. Good. Okay. So there are some cases where manipulating it can help you find that actual limit. The last one is if you had a number ending up over a 0, then you know the limit does not exist, okay? So in this case, if we're determining the value of this function at 2, we get the expression 3 divided by 0. So we know that anything divided by 0 does not exist. So if I plug a -1 in here, I'm going to get -1 minus 1 on the top, so -2 over 0. Because of that, I can just say right away that the limit does not the limit does not exist. Because even if I manipulate this function, I'm still going to get a number divided by a 0, and that does not work. Okay. So limits to infinity was the next thing that we talked about. And so remember that when you're solving for a limit to infinity, if you have like a graph, you're looking at the end behavior. So as this number gets super, super, super big, remember that that's basically the same as figuring out what the horizontal asymptote is. What is that value that it gets close to but never touched? So horizontal asymptote is basically the same thing. So you're going through a very similar process to what we did in Math 30. So the limit of this thing as x goes to positive or negative infinity So if we take $1 million and square it, if we lose $4 million, it doesn't matter. If we lose $19, it doesn't matter. So then we're just dealing with the limit as x approaches positive or negative infinity of x squared divided by 5x squared. In this case, the x squareds are going to cancel. So when I plug in infinity, there's no variable left to plug it into. So this is just going to equal 1/5. Okay, so for this one, we're going to say the limit as x approaches positive or negative infinity of ln x to the 4 over ln x to the 3. Okay, so we want to figure out how to simplify this. Now, if I take infinity and raise it to the power of 4 or a million or billion or whatever the number is, that's still, like, we still are lawning both. So remember that our log rules still apply. So that 4 and that 3 can come down. So this is the same as 4 ln x divided by 3 ln x. The ln x's can cancel, and now we just get 4 over 3 as our answer there. Okay. Other limit examples, remember that this guy is an identity. It's on your formula sheet. And its value is 1. So as x approaches 0, sine x over x is always going to give you 1. So this is going to be 3 times 1, so 3. Okay. You're not going to have to do sandwich theorem on the midterm, so don't worry about that. You are going to have to do something like this, okay? So finding the slope of a tangent. Oh no, you're not even going to have to do something like this. You can use the derivative of it. But let's still go over this. So there's two ways to do it. So either if you have your graph, it's going to look something like that-ish. So you've got this point 6, 7, okay? Either you can pick a point where your x value, so this one in question, is getting closer and closer and closer to 6. So remember, the idea of a limit is trying to get closer to that tangent as opposed to a secant, okay? So that's the x approaches a method. The other one is you can say, okay, I picked another point that's plus h distance away, and I want h to get smaller and smaller and smaller and smaller. So we're going to go through both ways. So the slope of the tangent is equal to the limit as x approaches a of f of x minus f of a over x minus a. Both of these are on your formula sheet. So your slope here, okay, the first thing we want to, so the 2 points in question, our first point is 6, 7, And then our second point is x and root 8x plus 1, right? If I plug a 6 in, this is what I get out of it, right? Because then 48 plus 1 root 49 is 7, okay? So there's our 2 points. So here's the x and then root 8 plus 1, and we want to see what happens as we bring that a value as close as we can to 6. Okay, so equals the limit as x approaches 6. So this is going to be y2, so x, or root 8x plus 1 minus y1, so 7 over x2 minus x1. So if I plug a 6 in, I get 0 over 0. So I have to manipulate. Okay, this is another situation where we're going to want to use the conjugate. So we're going to have root 8x plus 1 plus, or sorry, minus 7 still here. And we're going to multiply by plus 7s over x minus 6. Multiply all of this by root 8x plus 1 plus 7, 8x plus 1 plus 7. So we're going to get 8x plus 1, and we're going to get minus 49. And then we're going to get x minus 6 times this whole other thing, and everything is going to work out all nice and cancel if we just leave this as it is. So 8x plus 1 minus 49 is the same thing as 8x minus 48. If we take an 8 out, we're going to have x and then minus 6. Hey, look, there's our factor that matches. Oops, this is a 6, not a 0. Matches on the bottom. So x minus 6, hey, those are going to cancel. 8x plus 1 plus 7. Now we can plug that 6 in. So we've got 8 on the top, and then root of 8 times 6 plus 1 plus 7. So this whole thing is 49 plus 7 is 8 over 14, which is going to reduce, they both divide by 2 to 4 over 7. Okay, so that's method 1. And then we can do the different way, but we should get the same answer. So this is the limit as h approaches 0 of, and remember this time we're plugging the x plus h into the equation. So it's going to be 8x plus, or sorry, x is 6. 6 plus h plus 1 minus 7 over, so this is going to be 6 plus h minus 6, so it's just going to simplify into an h. So if we plug a 0 in, we're going to get root 49 minus 7, 0 over 0. So we have to multiply by a conjugate again. So it's almost like you're going to see this whole multiplying by a conjugate thing on the midterm. I guess I should really go make sure that that's true now that I've said it. You will see this. 6 plus h plus 1, and then plus 7. So this times this is going to be just 8 times 6 plus h plus 1. And then 7 times 7 is 49. So when we do this, we've got 8 times 6, which is 48, plus 1, which is 49. So all of that is going to cancel. So we're just going to be left with 8h on the top, and then h. Hey, look, those are canceling now. So now we can plug that 0 in. So we're going to have root of 8, 0 plus, oh, this is a 6. 6 plus 0 is still 6, plus 1, plus 7. Hey, look, we get 8 over 14 again, which is 4 over 7 again. So those are the two ways. Again, once we got past this, we just used derivatives to get it. So you will have to deal with limits, but you're not going to have to deal with this. But I wanted to talk about it just as a reminder of this is what we're doing when we're finding derivatives, is we're trying to get that secant to turn into a tangent by getting as close as we can to that point. So then we moved on to derivatives. So a derivative is going to exist if the function is continuous and does not show any of the following characteristics. So it can't have a cusp. So a cusp is like something like that. A corner has straight edges, and then a vertical tangent. So maybe it goes a vertical tangent like that, right? Because that slope is infinity, okay? And infinity does not exist because we can't define a real number as infinity. You need to know the derivative rules. So a power rule, if you have a to the x and you want to do the derivative of it, you take that x down in front, you multiply it by a to the x minus 1. If you want to do the derivative of u times v, it's going to be the derivative of the first one times the second one plus the first one times the derivative of the second one, or vice versa. I do it a different way every time. I can't keep it straight in my own head. If you're doing the derivative of a quotient, so u over v, I guess I should make that a good u. Remember that this is the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. This one matters. You can't mix up the order. The chain rule is if you're doing the derivative of f of g of x. How many brackets do I have? There. Wow. We're doing f prime with g inside it. So we're doing the derivative of the outside first and keeping g inside it, and then multiplying by the derivative of the inside. Okay, you guys know how to do this. I've already given you like a tricky something like this on a test, so you're not going to see that again. It's going to be straightforward. You're just going to have to use it. Okay, recall how to determine the tangent and the normal lines using slope point form. These are a good question to know how to do. Okay, so we want the slope point form for root x plus 2, where x is equal to 4. Okay, so the first thing that we want to do is figure out what the slope or the derivative is, because that tells us the slope. Okay, so the derivative of this, remember that this is the same as x to the 1/2, which is why I gave us 1. It's going to be 1/2 x to the negative 1/2, and then the derivative of positive 2 is just a 0. Okay, so this is going to turn into 1 over 2, and then this is going to drop down to the bottom as a root again. So y prime is equal to 1 over 2 root x. So at x equals 4, you're going to have y prime, which is your slope, so root 4 is just 2, so this is 1 over 4. Okay, so there is your slope. The other thing that we need to know is what is the y coordinate of this point before we can turn it into slope point form. Okay, so if I take 4, plug it in there, we're going to have root 4, which is 2, plus 2, so y is also equal to 4. So my point is 4, 4. Okay, remember then you're doing y minus y1 equals m x minus x1. So this, this is going to go in here and here. I drew that, but you get the point. So it's going to be y minus 4 equals m. So m is this guy. So 1 over 4 x minus 4. So So then 1/4 x, this is just -1. Add the 4 to both sides. So this is your tangent. Remember that your normal is perpendicular to your tangent. Perpendicular means a negative reciprocal of the slope. So normal is perpendicular, here's my little right angle, to the tangent. You want your negative reciprocal of your slope. So then you're just going through slope point form again. So y minus 4 equals, the negative reciprocal of this is, you flip it, and then you make it a negative. So it's going to be 1 over 4, or sorry, it's going to be -4 over 1, which we just don't write. So -4x, this is going to be +16, add the 4 to both sides. So y is equal to -4x plus 20. Okay, so you need to know how to produce both of those lines. So derivative to figure out the slope, then you're plugging the slope into the point form notation. Or so that, sorry, the point slope notation, point form. What is this, English class? Okay. Last thing that I want to highlight is you need to be comfortable with implicit differentiation. So you want to find this first derivative of x squared minus y cubed minus 9 equals 0. You only have to do the first derivative of something like this on the midterm, so you don't have to worry about the second derivative implicitly where you have to plug it back in. So don't worry about that. So when we're doing implicit, we're not rearranging and isolating for x. So we're doing the derivative of each with respect to x here, okay? So we're going to do the derivative with respect to x of the first term minus the derivative with respect to x of the second term minus the derivative with respect to x of the next term. And these are minuses because that's what's in between. If they were pluses, we'd use that. And then the derivative. So basically we're doing the derivative with respect to x of each of the terms in here, okay? So the derivative of x squared with respect to x, so that's just 2x, right? And then times the derivative of x is just a 1, okay? Then we've got the derivative of y cubed, so that's going to be 3y squared. And then we need to chain rule. Remember, we have to multiply by the derivative of y. That's what we're going to be isolating for, okay? So that's super important. And then the derivative of 9 is just 0. The derivative of 0 is just 0. So we're going to get -3y squared dy dx. And then I'm going to move the 2x over. Then we need to divide both sides by -3y squared. Cancel, so dy dx is -2x. I guess we can get rid of the negatives. So 2 over 3x over y squared. Okay, so an implicit differentiation is generally going to leave you a y variable, but you need to isolate for dy dx. Okay, so chain rule applies and you're isolating for dy dx. As far as studying, this stuff is okay. I'm not sold on it. What I would rather you guys do is go back through your notes, go back through your quizzes and tests, and make sure you can do the level of questions that are in those. So look at your notes from the beginning, cover up your answers, and work through those, okay? So find the ones like this question above here and like the one that I just started on the page before. There's going to be like one of each kind of limit question. And then definitely make sure you're okay with related rates and modeling, okay? So yeah, I would say going back through the stuff that you know how to do, that you have worked solutions for, covering up those answers, cover them with sticky notes, cover them with your hands, cover it with another piece of paper is going to be better than doing this stuff. The other thing that you should go back and look at, make sure you still know how to do, is doing stuff like y equals x to the x, okay? Remember that if you're doing a derivative like this, what do we do here? Okay, we talked about how we had to log or ln both sides so that that could come down. And then you're doing implicit differentiation with the log rules. Okay, so something like that is also very useful to do. So go back and look at those. If you guys have questions on any of that, let me know. But I don't think there should be any surprises on the midterm. I think you guys know your stuff as long as you take a bit of time and re-ingrain these things in your brain, because we haven't done them in a little while. So let me know if you have questions, and we're doing a live Q&A on Monday.